Okay, looking at the example on page 11, you have an electric device that's rated at 500 watts and it's on for 3 hours a day. They're giving you the cost of electricity per kilowatt hour. What's the cost for 100 years? For 100 days, I mean. So E is power times time. Now, if we want to do this in kilowatt hours, the power has to be in kilowatts and the time has to be in hours. So there are 300 hours in 100 days. And if you do the math here, you should get, what is that, 75? 150 it looks like. Yeah, 150, sorry. 150 kilowatt hour. Every kilowatt hour costs 12 cents, so you multiply this by 0.12 to get your cost in dollars. So it should be about $18. 24. What is the current drawn by a 100-watt light bulb operating at a potential difference of 120 volts? So power is I times V. 100 watts equals I times 120. You do 100 divided by 120 and you get a current of 0.83. 25. What is the resistance of a 600-watt microwave oven that draws a current of 5 amps? So I think I'm going to use the formula that says P equals I squared times R. 600 here equals 5 squared times R. So it should be 600 divided by 25, which is 24 ohms. What power is dissipated by an electric fryer pan that has a resistance of 12 ohms and operates at a voltage of 120? So for that one, we're going to do V squared over R. So it's going to be 120 squared divided by 12. So this should be, I think we can do that mentally, but don't feel like it. So 1200 ohms. Okay. Number 7, calculate the energy dissipated in 1.5 minutes when there is a current of 4 amps running through the potential difference of 60 volts. So energy is power times time equals power is going to be I times V, and the time is 1.5 times 60, and you get your answer in joules, and the answer should be 21,600 joules. Now if you want to find the energy in kilowatt hours, we have to take our power and change it to kilowatts and take our time and change it to hours. So the 1.5 minutes will be divided by 60 to change it to hours. And the power, it looks like it's 240, so it's going to be 0.240. And we should get 0.006 kilowatt hours. Okay, number 28. What power is supplied to a lamp that is operated by a 12-volt battery when current through the lamp is 12 amps? So power is I times V. So it's 2 times 12. So that's 24 watts. How much energy is being supplied to the lamp if it's been operating for 4 seconds? So it's E is a PT. So it's 24 times 4. So that should be 96 joules. Okay. Or if you want to do it in kilowatt hours, your power has to be in kilowatts and your time has to be in hours. Okay. So you take the seconds divided by 3600 and you get your kilowatt hours, which is very, very small. It's 1.67 10 to the negative 9. Let me try that again. It doesn't sound right. So 0.024 times 4 divided by 3600 Yeah, there's a mistake in here. So it should be 2.67 10 to the negative 5. Okay. I'm going to change that. Okay. Yeah, that's what it should be. Yep. Okay, 29. A current of 0.2 amps is kept flowing in a wire by a 10-volt battery for 5 seconds. What power is supplied to the wire? P is IV equals 0.2 times 10, so that should be 2 watts. Okay. How much energy? Well, energy is power times time, which is 2 times 5, so that should be 10 joules. Okay. Or you can change that to a kilowatt hour if you like. So to change it to kilowatt hour, it's going to be 0.002 kilowatts and 5 divided by 3600 to get your 5 seconds in hours. Number 30. How much energy is supplied to a 100-watt light bulb lamp in 50 seconds? So energy is power times time, and that should be 100 times 50, so it should be 5,000 joules. So if you want to write this in kilowatt hour, the power has to be in kilowatts, and the time has to be in seconds. So you divide 50 by 3600 to get your time in seconds. So it should be 5 over 3600. Okay. 31. Calculate the cost of operating a 400-watt spotlight for 2 hours a day for 30 days. So that's 60 hours. The cost of electricity is 8 cents per kilowatt hour. So I think we have to find the energy first. So that's power times time, and we're going to do this in kilowatt hour. So it's 0.4 times 60 hours. So what is that going to be? So that looks like it's 24, not hours, kilowatt hours. Okay. Now, in order to figure out the cost, you just take 24, multiply by 0.08, or you can do it by times 8 cents, get your number in cents, and divide it by 100 to get your dollars. So it should be $1.92. 31B. Find the cost of operating an oven for 3 hours if it draws 15 amp from a 240 volt supply. Okay, and they're giving you the cost of electricity. So I think we're going to say E is PT. The power is, we don't know, so we can find it by doing P equals IV, multiplying these two. So I V, and the time is 3. Okay, and that should give us 10.8 kilowatt hours. Okay, when it comes to the cost, you just multiply this number by 10 cents, and you should get $1.08. Number 32. Okay, the 400-watt computer, including the monitor, is turned on for 8 hours per day. If electricity costs 10 cents per kilowatt hour, how much does it cost to run the computer for annually for 365 days? For a 365-day year. So E is PT, power is 0.4. You're going to run this for 8 hours times 365 days, and that should be 1168 kilowatt hour. And all you have to do is you multiply that by $0.1, and you should get almost $117. If we try to figure out the slope of this, all we have to do is write power equals V square over R, or actually not V square over R because this is linear. So I square times R, and the slope will just be I square. So the answer should be D, and you should do it.